Okay, in this one I wanted to quickly show you the readv and writev syscalls, which are, I don't know, the vectorized version of the read and write syscall. So here you can see I have a little benchmark, and in this benchmark I have like a very dumb HTTP server as an example, and I wrote it with writev and just write. And you can see that the writev is basically kind of 33% faster than the write equivalent. And so yeah, let me show you why. So my example is this. So I mean, let's not worry about all the TCP stuff and whatever. You can watch my previous videos if you're interested about that. But basically, I have a TCP thing, I accept a client, I read stuff from the client, and then I form my body and my header. And so, of course, this is a bit of a, I don't know, a weird example because this is not how you would do it in real life, but let's pretend for the example that I have multiple buffers like this with the body and every single header, and I basically want to write them all to the client, and so I do one write per buffer. And so this is really inefficient because each write is a syscall, and syscall involve a lot more than your regular function, and so usually you try to limit them. And so let me show you how we can improve that. So I have the same file, but instead here, we're going to use writev. And so what writev takes as input is a list, well, an array of buffers and length of those buffers. So this is called iovec, like so. Let's just call it iov. And we're going to have this array, and each time we're going to say iov base is equal to our buffer, in this case the status, and then we're going to have the length of this buffer, which is simply going to be the string length in our case. So we can duplicate this in all of our example. Actually, let me just copy my example, it will be much easier, like so. And so now we have a vector of buffers, and what we can do is call writev on the client file descriptor, give it the vector and just the number of elements in this vector. So 1, 2, 3, 4, 5, 6, 7, 8, 9. This guy has 9 elements, and this will have the exact same behavior as what I showed before, but it will only have one syscall, and so that's why it can handle more requests per second. So of course this is very dumb, my example, because in real life you would just create a I don't know, a larger buffer, and then you would do sprintf in this buffer or snprintf, and you would put all the things in one buffer and then do a single write. I'm sure it would be, I don't know, the same time or equivalent time in our case, but this is not always possible. If your buffers are large enough, you don't want to move them around in memory because copying a large amount of data is also expensive, and so you can use writev or readv. Readv, by the way, I mean, I'm not going to show it, but it's exactly the same prototype, except that you read instead of writing. By the way, this is called, like, I don't know, scatter, gather, read, write, because the write gathers the buffers and the read scatters them. I'm not sure about the terminology, but that if you stumble upon it, that's how it's called. And finally, a little real-life example. I found the place in Nginx where they actually use writev. So from what I understand, they have this Nginx chain thing, which is like just a linked list of buffers, I think. And like for example, if you have a large HTML payload, and then you run your compress thing on it, you have multiple compressed buffers, I imagine. And so they here, if we look in this file for writev, we're gonna find it somewhere. So they have this Nginx writev, and so here, there you go, they call writev with vex IOVs. And I think this function above that I was showing, I think is just converting this linked list of buffer pointers and just putting it in the struct that the syscall wants. So yeah, that's about it for writev and readv. I hope you learned something, and I'll see you in the next video, probably about syscall again. See ya.